Hey guys, welcome to Calculus Day 21. Like I said, we're just going to spend a majority of our time looking at these specific functions, using the slope generating function to create the slope generating formula, and then plugging into that formula to be able to generate out the slope at various points. So for today, there's going to be a lot of algebra. It's going to be very algebra intensive. We're going to use this limit formula a lot. We're going to simplify this limit formula a lot. And then as we go through, make sure to note how we go through the process. And today we're going to focus on two types of questions. Trying to find the slope, which is one major type of questions that you'll see in calculus, and then how to find the tangent line, which is a related question. If you can find the slope, you can use the slope to find the tangent line, but you have to be able to find the slope first. So using that slope generating function is going to be super important. Make sure you know how to use this formula in particular very effectively, and let's get straight to it. Okay, let's take a look at our first problem. I'm going to start by doing a couple of the problems from last time's homework to get us used to be able to find the slope. Afterwards, I'm going to use some problems that are not assigned to you to talk about how to find not just the slope, but also determine the equation of the tangent line. For today, this formula, again, will be very specific, but I'm going to put one more up here because we're going to use it as well quite a bit. Y minus y1 equals mx minus x1. We'll use this formula to find the slope generating function. We'll use this formula to find the tangent line. Let's take a look, and let's start with some of the problems from last time. I'm going to do 6, 8, and 10, because those are ones that are good and representative of what we're talking about here. So let's take a look. Number 6. Number 6 says, find the slope of the tangent line to the graph of the function at the given point. So because we're trying to find the slope, we're going to know we have to use the slope generating function. And with that slope generating function, we need to be able to figure out what the slope is by plugging in this specific point. So let's look at number 6. We have 3/2 x. So we have g of x is equal to 3/2 x plus 1. And we're looking at the point -2, -2. Now, smart people will look at this problem and know you do not need calculus to solve this problem. But let's say you're in a rush, or maybe you're just, feeling like getting some extra practice. I'm going to do it the calculus way. And then at the end, I'm going to show you how we could have gotten this answer a lot faster using the algebra way. This is the only problem where you could do this on the homework. Well, this is number 5. Both could be done a lot faster if you look at this as an algebra problem, not as a calculus problem. But once you get to 7, 8, 9, and 10, that gets thrown out the window. You just can't do it. So let's take a look. So, in order to find the slope generating function, I'm going to plug into this limit. So the limit says, I take the limit as delta x approaches 0. That never changes. It's always delta x approaches 0. And then the first part is the original formula, but everywhere there used to be an x, I replace with x plus delta x. So instead of 3/2 x, I do 3/2 x plus delta x plus 1. So 3/2 x plus delta x plus 1. I then subtract from that the original function, which was 3/2 x plus 1, all over delta x. So I've taken my formula, and I've just plugged into that formula. Remember, this means take x and replace it with x plus delta x. So I took x and replaced it with x plus delta x. This means subtract the original function, so I subtracted the original function, and I divided it by delta x. Let's do this. Again, if I plug in delta x is 0, I end up with 0 divided by 0, which I know can't be the solution. And so I have to continue forward. Let's keep going. Limit as delta x approaches 0. On top, I can distribute the 3/2 to both pieces and the negative to both pieces. So I'd have 3/2 x plus 3/2 delta x plus 1 minus 3/2 x. I distribute the negative to both pieces, so that'd be minus 1 all over delta x. Again, if I plug in delta x is 0, I know I'm not finished because I have 0 divided by 0. Let's see what simplifies. Okay, I have positive 1 and negative 1. Those are going to cancel because they're both on top. I have positive 3/2 x and negative 3/2 x, so those are going to cancel as well. This leaves me with the limit of the remainder. Delta x approaches 0 On top, all I have left is 3/2 delta x, and on bottom I would have delta x. Now that I'm here, I can see that the delta x and delta x can cancel, leaving me with the limit as delta x approaches 0 of 3/2. Remember, the limit of a constant is just the constant, so it's 3/2. Now, I told you at the beginning there's a faster way. Well, that's because this is a linear equation, right? It's an equation where we have x to the first power. And so if we look at the original equation, well, we can clearly see that's the slope. And if it's the slope here, then it's the slope everywhere. So that means that not only is this the slope generating function, this is also just the slope, whether we're at -2, or any other point. Because this is a linear function, it has a constant slope, therefore the slope is 3/2. And notice we get that answer the calculus way, it just takes longer. And so look for those things to be able to figure out how to do these problems just a little bit faster, a little bit easier. Use all of your skills that you have in your big toolbox. Let's look at number 8. 8, you have to use calculus to get the answer. You can't cheat by using algebra. So let's look at 8. 8 says, let's take the function g of x is equal to 6 minus x squared. And we'd have 1, 5 as my point. If I was to graph this function, obviously this would be the slope at that function, but we'll get to that later. This one's a lot more interesting to do anyways. So, yes, I know it's g of x. You could obviously change this formula to have these both be g's instead of f's, but they're all the same thing. Don't get me started. Don't let yourself be trapped in the mindset of it has to be g, it has to be f. In this case, my original function is an arbitrary function where it can be any f or g or h or q if you want it to be. Just got to plug it in. So I do the limit as delta x approaches 0. I do the original function, which is 6 minus x squared. But instead of x, I replace that with x plus delta x squared minus my original function, which was 6 minus x squared all over delta x. So my original function of x plus delta x minus my actual original function all divided by delta x. Alright, let's do some algebra. The limit as delta x approaches 0. Again, if I plug this in, I don't get a solution, so I know I need to keep going. I'd have 6 minus, okay, x plus delta x squared. I can use the perfect square formula from Algebra 2 and College Algebra, which would tell me that this is x squared plus 2x delta x plus delta x squared minus 6 plus x squared all over delta x. Now I can simplify some more by distributing the negative into each piece. So I'd have the limit, be consistent, man. The limit as delta x approaches 0 of, I'd have 6 minus x squared minus 2x delta x minus delta x squared minus 6 plus x squared all over delta x. Now, I can see that some of these pieces are going to cancel. The positive 6 and the negative 6, the negative x squared and the positive x squared. This would leave me with the limit, as delta x approaches 0, of negative 2x delta x minus delta x squared all over delta x. Again, if I try to plug this in, I don't get a solution, so I keep going. I'm now going to factor, taking a delta x out of the top and bottom, limit as delta x goes to 0 of delta x times negative 2x plus delta x all over delta x. I can see from this I have delta x on top and delta x on bottom. They're going to cancel, leaving me with a limit as delta x approaches 0 of negative 2x. Oh, it should be minus. Why did I change that? Minus delta x. At any point in time before this, if I had tried to plug in, I would not get a solution. But now that I have gotten rid of the delta x on bottom, I can actually plug in 0 and get an answer. And when I do, I end up with negative 2x as my slope generating function. Now, this is the slope generating function. It is not the slope. The slope is found by taking that point, 1, 5. We take it and we plug in the x value. So we plug in 1, which would tell me that the slope in this case is negative 2 times 1, or negative 2. So we take the x value from my point, we plug it into my slope generating function, and that will tell me the slope of the tangent line at 1, 5. And here's the thing, if I open up Desmos, I should get the exact same slope, which means that I can predict how this function is going to look around 1, 5. Now I can't predict what's going to happen around other points, but specifically around 1, 5, I have a negative slope, and it's a slope of negative 2, which means it's going to be going down, and fairly quickly, not the fastest, but it's going to go down more than normal. Let's pull up Desmos. So I got Desmos here, I type in my function, which was 6 minus x squared. Oops. I can see over here at 1, 5, right there, we definitely have a graph that is going downwards over time, and it appears to be fairly steep. And now I'm going to answer the secondary part that we talked about, how to actually find the tangent line. This is what today's material is about. What we do is we take this slope that we have and we plug it into that formula. So we use this as our m, and then we use the two values we have for x and y to plug in and get the actual slope. So my slope, in this case, is negative 2. My point is 1, 5. So my tangent line would be y minus 5 equals negative 2, x minus 1. And if you're one of those math people that likes to simplify stuff, A, have fun with that. You don't have to, especially in tonight's homework. But B, if you did, then you will get the following solution instead. Y equals negative 2x plus 7. And so if I come here, if I was to graph that equation, y equals negative 2x plus 7, you can see that this represents the slope at 1, 5 perfectly. It's beautiful. Notice how we found those components one more time. Your homework said just to find the slope, so in your homework you would stop right there. We used the slope generating function, went through the algebraic steps to find the slope generating function, then we plug into the slope generating function to find the actual slope. This is the function, this is the slope. You have to actually plug it in. You're not done until you plug it in. We didn't have to do that on the previous one because there was no x to plug into. It was a linear function, which means the slope is always the same, which is why it was always going to be 3/2. Let's look at number 10. Same way. I'm running out of paper. All right. Desmos, go away. There we go. Okay, number 10. This one says, oh my gosh. Oh, devil upon devils. It says h of t equals t squared plus 3. And the point we're working at is negative 2, 7. Oh no, it's h of t. What do I do? Think of t like x and do everything the exact same. So instead of plugging in x plus delta x, you would just plug in t plus delta t. It's the same function. Don't make this harder than it is. It's calculus. It's not brain surgery. Okay? So let's try this out. Let's find the slope generating function. So we do the limit as delta t approaches 0. On bottom, I would have delta t. On top, I would have t plus delta t squared plus 3. There's my first function. Minus my original function, which was t squared plus 3 all over delta t. Notice I have extra parentheses here. I'd rather have extra parentheses than not have the right parentheses. Make sure the subtraction sign should be applied to the entire function, and the t plus delta t should be plugged in everywhere there used to be a t. Well, let's start doing some calculus. Limit delta x approaches 0. Or in this case, delta t approaches 0. I use the perfect square formula. T squared plus 2t delta t plus delta t squared plus 3 minus t squared minus 3 all over delta t. Again, if I try to plug in delta t is equal to 0, I don't get a solution, so I know it's not done, so I keep going. I simplify some stuff. Limit delta t approaches 0. So I would get rid of the t squared and the negative t squared. I get rid of the positive 3 and the negative 3. This would leave me with 2t delta t plus delta t squared all over delta t. Again, if I plug in delta t equals 0, I don't get a solution, so I know I'm not finished yet. But I can factor this out. Limit delta t goes to 0 of delta t times 2t plus delta t all over delta t. I cancel out those delta t's. This would give me the following equation. The limit as delta t goes to 0 of 2t plus delta t. I actually plug in delta t equals 0 now because I can get a solution now, which would tell me that the slope generating function is 2t. Beautiful. Beautiful. Which means my slope at negative 2, 7 would mean I want to plug in negative 2 as my t. It's always the first value is assumed to be your primary variable. So in this case, negative 2 is going to be my t. So I'd plug in 2 times negative 2, which is, of course, negative 4, and that would be my slope at that function. Now, this did it in t. Desmos doesn't like doing things in t, so I will convert it into x's. But this means that at this point, negative 2, positive 7, I should have a slope of negative 4. And just like before, if I wanted to find the tangent line, which is tonight's homework. Again, if it's last night's homework, you'd stop here. If I want to find tonight's homework, I do y minus my y value, which was 7, equals negative 2. No, it'd be negative 4. Negative 4 x plus 2. This would tell me that's my slope. Let's pull up Desmos. Put this down a little bit so we can see what we have Desmos open. Boom. Alright. My fictional function was t squared, so it's going to be x squared plus 3. And my new function, I'm not going to bother doing any fancy changes to this. Y minus 7 equals negative 4x plus 2. I can see that over here at negative 2, 7, this blue line perfectly represents the slope at that place. So it's the tangent line, which means my slope of negative 4 was correct. That's pretty incredible, you know? Is that it does stuff like that. And that's how it should work, is that it should always be able to tell me what the slope is doing at that particular point. Now, if I was over here, at 1, 4, I'd have obviously a different slope. And I could find that slope just by plugging it into my slope generating function. So if I was to ask on this problem a follow-up question that said, okay, what would happen? Follow-up question. What would happen at the point 1, 4? What would be the slope? Well, I could use the slope generating function I already found, which is 2t, to tell me that, well, at 1, 4, it would be 2 times 1, so my slope would be 2. And then I could use this slope to find the tangent line, y minus 4 equals 2x minus 1. And you know what? If I do that, y minus 4 equals 2x minus 1. Look at that. This green line represents the slope at this different point. Yet they both find the slopes from the same slope generating function, this 2t. We went through this whole process of finding the slope generating function so that no matter what point I'm looking at, whether I'm looking at negative 2, 7, whether I'm looking at 1, 4, I can find the slopes at those individual points, which is pretty incredible. Now, today's material takes this concept and takes it the next step farther, where it says not just to find the slope, but to actually find the tangent line like we've done in practice. Let's do a couple of those together, and then I'll release you guys to do your own thing. Now, the more extreme your function is, the harder this is to do. So I've assigned 25 to 32. It's a total of 8 problems. I'm going to do 2 of them with you. Now I'm going to try to pick the weirdest ones that I can to showcase how these rules kind of fit together. Let's start with your homework tonight includes number 26. This is the basic one. Okay, it says find the equation of the tangent line, then use the graphing utility to do the same. It says to use the derivative feature of your graphing utility to confirm your results. I haven't taught you that. You can skip part C. It's useless. Okay, 26. My function in this case is f of x is equal to x squared plus 3x plus 4. Okay. And the point we're looking at is at the point, what is that point? It's at negative 2, 2. There we go. Okay, let's close out Desmos. You can see this, it will not be hidden. Okay, this is my problem. We're asked to find the tangent line, so we're going to go through it the same way we did before. Now I'm going to work a lot faster on this one because you should be getting practice doing these limits. So make sure you follow along. Limit delta x approaches 0 of x plus delta x squared plus 3 x plus delta x plus 4 minus x squared plus 3x plus 4 all over, my parentheses are all over the place, delta x. Okay, let's go ahead and do our first limit. Limit delta x approaches 0. Okay, if I square these, I end up with x squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x plus 4 minus x squared minus 3x minus 4 all over delta x. From here, cancel, 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 cancel. I'm left with limit delta x approaches 0 of 2x delta x plus delta x squared plus 3 delta x all over delta x. From here, I can factor out the delta x, give me the limit delta x approaches 0 of delta x times 2x plus delta x plus 3 all over delta x. I can cancel, giving me limit delta x approaches 0 of 2x plus delta x plus 3. I can actually plug in 0, which would tell me that my slope generating function is 2x plus 3. So, this is my slope generating function. Let's find the actual slope. So my point is at negative 2, 2. So I would take that 2 and plug in negative 2 plus 3. So this is my slope generating function where I've plugged in negative 2, which came from my point. Which, if I simplify that, I would get a slope of negative 1. To find the tangent line, all I would then do is use that formula, y minus y1 equals m parentheses x minus x1. This would be my tangent line, which means I'm done. I could, of course, simplify that, which would give me y equals negative x. Well, let's pull up Desmos, see if we're right. In theory, if this is correct, this would be my equation, which I need to plug in first, And this would be a tangent line that goes through this specific point. Desmos, come here. It's time. Okay, which equation was x squared plus 3x plus 4. And my point was, oops, y equals negative x. Look at that. It goes to the point negative 2, 2. Hey, come on. It goes to the point negative 2, 2. And it represents the slope at that point. Yeah, I'd say so. Yeah, look at that. That's beautiful. And so that's how you do your 2 parts of your homework. You have to use the slope generating function to find the slope, and then find the equation of a tangent line, and then verify your results using a graphing calculator. Desmos is great for this. But you need both. You need to find the slope generating function, use that to determine what the slope is, then use the slope to find the equation of the tangent line. And you can leave it in this form or you can simplify it farther. I'm fine either way. You have 8 problems to do. Now, we've talked mainly about polynomials, but this process works the same even when you're doing it to non-polynomial functions. So for example, where tonight gets fun is what happens if you have something like a radical. This is one of your homework problems tonight. It's number 30. And number 30 states, what happens if f of x is equal to the square root of x minus 1? And we're looking at the point 5, 2. We're asked to, dang it, Desmos, get out of the way. We're asked to determine what the tangent line is for this function at this point. So that's what we're going to do. We're going to determine what the tangent function is and find the slope generating function using that same formula, but now we're going to have to do it with this thing. Ready? So, limit delta x approaches 0. We would use the square root of x plus delta x minus 1 minus the square root of x minus 1 all over delta x. The trick here is that if you've forgotten some of your algebra skills, you get stuck after this step. So you would do the limit as delta x approaches 0 of the square root of x plus delta x minus 1 minus the square root of x minus 1 all over delta x. If you're stuck here, it's because you've forgotten some of your algebra. Okay? To get rid of nasty radicals like this, one of the things you can always do is use a conjugate. So I'm going to use the conjugate, the square root of x plus delta x minus 1 plus x minus 1. I'm essentially conjugating the top as opposed to conjugating the bottom. This will allow me to simplify this radical and get rid of both of them on the top. Now, it's not going to do anything nice for the bottom, but that's actually okay. We don't care about the bottom because the bottom is a delta x, and that's already a problem. So if we can do something to get rid of the top, maybe they'll fix the bottom at the same time. So, next step. The reason we use a conjugate is because the conjugates, when you FOIL them out, will cause the radicals to disappear. X plus delta x minus 1 minus x minus 1. That's what happens on top, is the radicals end up disappearing because we used, remember, this is called a conjugate. This is really common mathematics and algebra to do. You may have forgotten it, relearn it, it's useful. So, use the conjugate to get rid of those radicals. On bottom, I'm just going to leave it as we wrote it, which was square root of x plus delta x minus 1 minus square root, or sorry, plus square root of x minus 1. The reason I'm going to do that is because watch what happens to the rest of it. I don't want to simplify that bottom piece because it doesn't simplify. But watch what happens to the top piece. I can distribute my negative. This would become x plus delta x minus 1 minus x plus 1, which I can clearly see the x and the negative x are going to cancel, the negative 1 and the positive 1 are going to cancel, leaving on top, all you'll end up with is limit delta x approaches 0. On top you have just delta x. And on bottom you have delta x times this nasty parentheses. Why is that good? Well, we can cancel on top and bottom. Negative and negative, or the delta and delta are going to cancel, leaving me with the limit as delta x approaches 0 of 1 over square root of x plus delta x minus 1 plus square root of x minus 1. And at this point, we can actually evaluate this limit. We plug in 0. This would become 1 over square root of x plus 0 minus 1 plus square root of x minus 1, which after some algebra becomes the square root of 2 square root of x minus 1. So this is my slope generating function. It is not the slope, it is not the tangent line, it is the slope generating function. So to find the tangent line, I now need to find the slope. So I'm going to take that information and I'm going to try it out at 5, 2. So I plug in 1 over 2 square root of 5 minus 1. When I plug that in, I can end up with 1 over 2 square root of 4. Square root of 4 is 2, so this becomes 1 over 4. That tells me my slope is 1 over 4. Now I can plug this and my slope into my function. Y minus 2 equals 1/4 x minus 5. And there's my tangent line. Let's verify with Desmos, and we'll call it a day. Give me Desmos. Alright, my original function was the square root of x minus 1. My equation is unsimplified because I'm lazy. Y minus 2 equals 1/4 x minus 5. Look at that. Look at that beautiful purple line. Wow. Big things to note. We had to use a conjugate to fix this problem. On one of the other problems you have tonight, you will also use a conjugate. And on another problem, you may end up having to simplify some complex fractions. That does not mean it has it means it has fractions within fractions. Use every algebra trick that you know, and if you get stuck, that's okay. I'm going to go through those two problems next time as well, just to give us some extra practice. That'll finish with us today. That'll be, this is like I said, the last video topic we have to discuss, and I've already sent out the pros test. Make sure that gets done by Thursday at noon. If not, I can't grade it. I'll see you guys on Wednesday as our last day.